All right, now the good news is, in practice, you don't implement Euler's method by hand, but you do it with the help of a computer. So today I want to show you how to use Python to apply Euler's method with 100 steps to approximate the following ODE under interval 0, 10. So what you want to do first is to go to Python. So on your favorite web browser, go to the Jupyter Notebook. You click on this, click on try it in your browser, Jupyter Lab, and you open a new notebook. And yes, it's the 12th time I'm trying this actually. And the first thing you want to do, you want to import your external libraries. So import NumPy as NP, sort of the symbolic calculator. And then from matplotlib, import pyplot as PLT. That's sort of the plotter. And you have to wait here until the star becomes a number. So beware, the kernel is sometimes busy. So if it doesn't work one day, you can try it the next. Hopefully not days, but you get the idea. Okay. Then we want to import the basic data. So our interval is 0, 10. So the left point is 10. Sorry, left point is 0. The right point is 10. Our initial condition, y of 0 is 1. And then we have 100 steps, meaning 101 points. So that's the way it works here. Like 101 Dalmatians. And then h, as usual, is b minus a over 100. So n minus 1. That's one thing. And then we want to generate our t values. So t0, t1, up to t100. There's a very convenient way of doing this using what's called linspace. So from 0 to 10 with 101 points. And this will generate the interval, 0, 0.1, 0.2, up to 10. And then we want to initialize the y values. And the way we're going to do this is we start with a vector of all zeros and successively update them. So this is a y vector. And then the first entry is the initial condition. And for I in range 1n, so she doesn't have the range, we want to apply the ODE. So the future is the present plus the ODE. So minus y I minus 1 plus np dotted sign t I minus 1. Okay. And let's see, I think there's an extra parenthesis here. Okay. And don't forget about the indent. So again, we start with a vector of all zeros. The first value is the initial value, and then we just successively update them. And by the way, you can even print the values by saying print TIYI, but that's not what we're looking for now. Here we want to plot. So we use PLT plot. Sounds like BLT. So the t values, the y values, and with little circles, we can even label x label value t, PLT, y label value of y. And then with a Q title, approximate solution with for Euler's method. And then PLT show. And then what we get is, if it works, hopefully this beautiful plot. Oh, it works. I'm always nervous that it crashes. But anyway, we get this beautiful solution, this beautiful plot, of using Euler's method with 100 steps.